Great to meet y'all. It's really a pleasure to be able to join y'all today. So like Evan said, my name is Jonathan. I'm currently a PhD candidate at MIT, and I work with a research group called the Visualization Group, and we do a lot of things related to data visualization and communicating with data. And in particular, my focus in my research has been on accessibility. So how do we make charts and graphs more usable, more enjoyable for people who are blind or have low vision? So I'm going to talk a bit today about some recent work that we've done around kind of developing richer screen reader experiences for accessible data visualization. And this work is a collaboration with a bunch of other really awesome folks in my lab. So be sure to check out our website if you're interested in more info. Cool. So you may already be familiar with this statistic, but according to a survey from the National Federation of the Blind, there's upwards of 7 million people in the United States with a visual disability. And despite the kind of prominence of visual disability in the US, when it comes to web accessibility, 96.8% of the top million pages on the internet kind of fail to meet basic accessibility standards for making content usable for people who are using screen reader assistive technology to browse the web. And I'm sure many, probably most of us are familiar with screen readers since this is a design for assistive technology class. But I'm just gonna quickly demo what a screen reader is, just to make sure we're all on the same page. So sorry, I should have pulled this up earlier. So I'm gonna open up VoiceOver, which is a screen reader that's built into macOS.
VoiceOver on Safari.
I get nervous because it does funky stuff with Zoom sometimes. But all right, so
rich screen reader experiences for accessible data visualization, vertical line, MIT Visualization Group.
So a screen reader is basically this assistive technology that has a cursor that is represented visually with this black square. And this cursor can be moved around a web page using arrow key combinations. And it basically just converts whatever text it's highlighting into speech and reads it out. So
rich screen reader experiences for accessible data visit link heading level 1 hi visit link home middle dot link publications middle dot link videos link heading level 1 rich screen reader experiences for accessible data visualization.
So kind of like that.
VoiceOver off.
All right. But when it comes to using screen readers for data visualization, it's a little less straightforward, right? Because a lot of data visualizations, aren't primarily textual. They involve images. And when people, remember to include text descriptions for the images, maybe you can get like a couple sentences out, but largely the kind of default experience for data visualization is something like this when you're using a screen reader.
Image, 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 one face, image, logo other, image, image.
Right, so that's kind of not great. And so, because so much information on the web is conveyed through charts, and a lot of this information is about stuff that can be pretty important to people, like election results or like information about COVID-19. It's pretty important that we make sure that everyone can get access to this information, right? So the goal of my work with the MIT Visualization Group has been to think about how do we make these charts more accessible to screen reader users? And I'm just going to talk through some of the kind of like current existing approaches using this US election map from that video as an example case. So the primary two recommendations that most people have for making charts accessible to screen readers is either to add alt text, which is an alternative textual description of what the chart represents, or link to a data table that kind of has all of the like, you know, raw underlying data as a kind of like spreadsheet table format. So I'm going to talk about both of these approaches and kind of the pros and cons of each. So an example alt text for that election chart might read something like this. Map of 2020 US presidential election results. Joe Biden has 227 electoral votes. Donald Trump has 213 electoral votes. 98 votes remain. And you know, this is pretty good. This is definitely much better than image, image, image. And it kind of gives you an idea of the broad message, like the high level message of the chart. But where does this approach fall short? So some of the limitations of alt text are that it's kind of this single static interface. So you can't really interact with an alt text. Like what you get is kind of just what you get. There's no control over information granularity, which is a word that we use to describe like how detailed you're kind of going in. So for example, if you wanted to figure out like, okay, Joe Biden has 227 electoral votes, which states are these votes coming from? You could do that with the chart as a sighted person, but if you only have the alt text, then you can't really kind of dive into the details like that. And finally, there's kind of a lack of user agency. So if all that's provided on the website is this alt text, it's hard to kind of like read this and then kind of like ask new questions about the data, right? Or like come up with your own questions. You can only really answer the question that the person writing the alt text had in mind initially as like the high level summary. Okay, so that's alt text. What about data tables? So the data table equivalent to that election map would probably look something like this. So there's, you know, a bunch of different rows that have information about votes in each state, kind of broken down by, you know, who the candidate is, what party they are, etc., how many votes. So all of the, you know, same information that you would be looking for from the chart is also in this table. And this does a bit better than alt text on the user agency front, right? Because you can kind of, a user can kind of go through and explore on their own and like ask their own questions about the data and, you know, like find maybe unexpected things, but it does have some drawbacks, right? Data tables can be pretty tedious and time consuming, especially if you're using a screen reader. You're going to have to read out, you know, every single row one at a time. And that would just take much longer than anyone would want to spend reading a chart. And there's also this issue of it requires high cognitive load to understand patterns. And what I mean by that is, you know, you have to remember a lot of stuff when you're going through this table. And like, if you want to kind of understand a pattern or a trend, you have to remember the numbers from the previous rows and kind of compare them to what you're reading now. And you would probably want to, like, you know, break out a pen and paper or something for that, because it's just really hard to hold it all in your head. So finally, with data tables, there's kind of no equivalent to like this narrative or interpretive effect of visualization. So charts and graphs do more than just kind of directly translate data into visuals. They're also kind of telling a story with the graphics and kind of guiding you through certain interpretations based on the choices of like what colors are used or like what, you know, what data fields are represented. So there's kind of more that's going on with charts that you know, helps someone understand what's happening than with like a kind of unstructured data table. Cool. So, you know, despite all those drawbacks, alt text and data tables are still really important to include, and they're you know, having both is often like really helpful for a lot of people. But at the same time, a lot of people are thinking, well, you know, how do we kind of improve on these limitations, right? And so I kind of want to talk about some examples of like what current like custom screen reader interfaces for data visualization look like. And I think a good example of this is this demo from HighCharts, which is a data visualization library, and they have an accessible version of a line chart on their website.
1. December 2010, 34.8%. NVDA. 1. December 2010, 20.2%. VoiceOver. 2. May 2012, 30.7%. VoiceOver. 3. January 2014, 36.8%. VoiceOver. 4. July 2015, 30.9%. VoiceOver. 4. July.
Cool. So, you know, what's going on here is there's like a kind of arrow key navigation that lets a user browse around different data points on the chart, and it'll read out just the data for that point. And so it kind of, like a data table, it kind of lets you explore around, you know, control your own navigation while still kind of giving you information. This is definitely helpful, but it's still kind of like very like a data table. It's very like low level, right? You're still kind of reading off individual data points, so you don't have control over like the level of detail that you're reading. It's harder to zoom back out into the kind of like high level summary that maybe an alt text would give with only this interface. So the idea that my collaborators and I were kind of trying to explore is thinking about like thinking about a set of design dimensions for thinking about richer screen reader experiences for visualization that are maybe kind of more that offer more like control over like coming up and down like different levels of detail and like exploring different parts of a chart. And what I mean by design dimensions is we wanted to think about, you know, not only how to make interesting like software prototypes or like make a library, but use that process of designing the interface to come up with like a framework or a set of design considerations that, you know, anyone who wants to design screen reader interfaces for visualization might find helpful to think about. So our interest was kind of not only producing the software, but also like kind of figuring out how to think more systematically about the design process for making this kind of thing. And I'm going to start by showing a demo of one of the prototypes that we made during our design process, and then we'll kind of talk about it and talk about our process for coming up with these prototypes. So, all right. Pulling up my screen reader again.
Random access, vertical split, random access, in random access, web content, a scatter plot showing body mass and flipper lengths of penguins. X-axis, a scatter plot showing body mass.
Okay, cool. Whoops. Is the voiceover window visible? No? Yes? Okay. I think that meant yes. All right. Cool. So imagine you're on a web page and you are browsing it with a screen reader and you come across this scatter plot. So the idea is that when you first encounter the scatter plot, you might be able to read out a kind of short, just high-level summary of what the scatter plot is. So maybe kind of similar to an alt text that you would get at the top level. So in this case, it's
X-axis titled a scatter plot showing body mass and flipper lengths of penguins.
right. So scatter plot showing body mass and flipper lengths of penguins. The idea with our prototype is that you can use the up and down arrow keys to kind of move up and down different levels of detail. So we're kind of at the top level right now. And if I want to move down one level, I can get information about the different axes and legends on the chart. So I'm going to press the down arrow key.
X-axis titled flipper length for linear scale with values from 170 to 240.
And now I'm on this the second level, and I can use the left and right arrow keys to kind of cycle through the different axes and legends that are all on this level. So that was the x-axis. Here's the y-axis.
Y-axis titled body mass G for linear scale with values from 2,500 to 6,500. Legends titled species for color with 3 values. Adelaide, Genstrap, Gen 2. Grid view of scatter plot.
And there's a grid view at the end. Cool. So let's say I want more information about the x-axis. So I'm going to go using the left arrow key, go back to the x-axis, and then press down again to descend into the x-axis.
Legend y-axis x-axis titled flip range 170, 180, 8 data values in the interval.
So on this level, like kind of below the x-axis, I'm now kind of navigating through this list of the different range intervals along the x-axis. So if I go left and right here.
Range 180, 190, 69 data values in the interval. Range 190, 200, 113 data values in the interval.
So it's reading out the range and then how many data points are underneath. So I can kind of like page through and get a sense of like the distribution of the data, like where is most of the data in this chart? Where is there less data?
Range 200, range 200, range 200, range 230, 240, 8 data values in the interval.
Great. So let's say I'm curious about, I think there was the most data like between 180, 190. I can left arrow back over there and then press down again to descend into that section.
Range 100, range 180, 1 of 69, flipper length 180, body mass G, 3,700, species, Adelaide.
Great. So now I'm at the very bottom and I'm kind of at the level of individual data points. So kind of like using a table. Now I'm reading like single entries on the scatter plot. So, you know,
2 of 69, flipper length 180, body mass G, 3 of 69,
etc. There's a lot of those. Cool. So I'm going to navigate back up.
Range 100, x-axis titled flipper length for linear scale with values from y-axis titled legends titled species grid view of scatter plot.
And I'm going to talk a bit about this grid view. So I just kind of showed like you can navigate around this visualization in this like kind of hierarchical structure where you can like narrow in on different parts of the visualization. What if I kind of just want to like, instead of navigating that way, just move up and down the grid of the scatter plot, kind of like, you know, if you imagine the scatter plot was like a tactile graphic instead, that was like either, you know, embossed on paper or 3D printed, kind of similarly to how you would like feel up and down the grid with your hands. I want to be able to do that kind of navigation with this prototype. So I'm going to go into this grid view section and then
0 data values in the interval, body mass G, 6,000, 6,500, flipper length 170, 180.
And on this level, I actually have these like grid squares where it's kind of giving me a range on the X and the Y axis. And I can use the WASD keys to move like up and down the grid. So
0 data, 6 data, 2 data values in the interval, 5 data values in the interval, body, 60 data values in the interval, body, 79 data values in the interval, body mass G, 32 data values in the interval, body mass G, 4,000, 5,000, 25 data values in the interval, body mass G, 4,000.
So it's kind of giving me the number of data values underneath where I am again, and I'm like moving up and down the grid, and it's just highlighting what's inside of the square that I'm on. And just like before, I can kind of enter into these squares.
1 of 25, flipper length 200, body mass G, 4,000.
And I can cycle through the individual data points that are inside of the square that I'm highlighting. Cool. And then last thing on this prototype, what if I, you know, have like a certain part of the visualization that I'm interested in looking at, but I don't really want to figure out how to like find my way there with the arrow keys, right? So we have this last thing where you can press the R key.
Open navigation menu. Use dropdowns to navigate.
And it brings up this navigation menu with dropdowns. The dropdown, there's a dropdown menu for each layer, and each of the entries in the dropdowns are like different locations in the visualization. So you can use your kind of usual screen reader commands to use these dropdowns, and it'll just jump you directly to whatever location you select instead of having to kind of arrow key there. So I'll just demonstrate that real quick.
Open navigation menu. Layer 1. Grid view of scatter plot. Layer 1. Menu. 4 items. Checkmark. Grid view of scatter plot. X-axis titled flipper length. Y-axis titled body mass. G for a linear scale with values. Legends titled species for color. Legends titled species for color. Closing. Layer 2. Add delete. 1. Menu. 3 items. Check. Gen 2. 123 data values and category. Gen 2. 123 data values and category. Closing menu.
So I navigate to the legend, and then I picked the Gen 2 category, and now it's highlighting just the Gen 2 penguins on this penguin scatter plot. And then I can just press escape to exit out of the
close navigation menu,
and then go right back to kind of the up down arrow key.
1 of 123 species. Gen 2 flipper length. Gen 2 123 legends titled species for color with 3 values. Gen 2 123 data. Gen strap 68 data val. Add delete 151 data values and
cool. All right, back to slides.
Voiceover off.
Actually, so why don't I pause for questions real quick about any of the stuff I've talked about so far, and then after that we'll kind of actually, no, sorry, I'm gonna unpack what we just looked at, and then I'm gonna pause for questions. All right, cool. So yeah, just to kind of talk a bit about what I thought was maybe interesting about the prototype we made in terms of like how it was different from like prior screen reader interfaces, right? Like the high charts example, like line chart thing that we saw earlier. So some of the characteristics of our prototype were that one, it had a hierarchical structure, right? So in addition to kind of moving around the visualization, you could also move up and down different levels of detail, right? You started at the top level, got this kind of high level summary, and then you could drill down into like sub parts of the chart, axes, legends, and then like intervals and categories underneath that. Finally, individual data points. So you kind of like control the zoom in and out. Our prototype had multiple ways to navigate. So you could navigate kind of along this hierarchical structure, going up and down, left and right. You could navigate spatially, kind of as if you were like feeling around this visualization, like up and down the grid. And you could also jump directly to locations if you didn't want to figure out your arrow key situation, but like had a location in mind. And finally, we had all these descriptions. We had multiple descriptions, right? Instead of just the one from the alt text. But you didn't have to listen to all of them at once. And they also had different levels of information granularity. So there were like specific descriptions of like what individual data points were. There were descriptions about like how many values are underneath a certain part of the chart. And there were kind of more like high level summary descriptions of just like, what does this stuff represent? Cool. What are your questions about anything I've shown so far?
So I have a quick question. I know that for screen readers, like on your phone or something, sometimes they'll like highlight the text it's reading, like they'll outline it in like a little box maybe.
Mm-hmm.
I was wondering if the screen reader on the Mac did that.
Oh yeah, it definitely does do that. Maybe that was not getting screen shared properly over Zoom. But yeah, so like on my end, it's showing a little like black square across what it's yeah.
Yeah, maybe because like I don't know if you have to share your whole window. If you're just sharing like your just the like Safari or something, it might not show up, but the whole window.
I see. Yeah, I think that's what's happening. I'm just sharing Safari.
Okay.
Maybe I can fix that right now.
Another quick question for you, just while you're playing around with that.
Mm-hmm.
I'm assuming people who use the system are used to, hearing the text quickly, stuff like that. But are you able to slow it down?
Yeah, absolutely. That's a really great question. So that's a setting that's customizable in the VoiceOver settings. So it's not part of my prototype. It's part of the screen reader settings itself. But yeah, like you said, different people have different experience levels with like listening to screen readers, and people have different preferences about how quick they want the speech to be. And I'll talk a bit about this later, but I think like customization is one of those really important things that I want to keep thinking more about, because everyone has got like different preferences and needs. So yeah.
Well, I have a question. So like I know what like the screen reader is for, but what are like the types of people that use the screen reader?
Yeah, definitely. So the main category is people who are blind or have fully lost their vision. But actually, the screen reader is something that's used by people with like a whole range of kind of visual ability. So I'll talk about this a little more later, but when we ran a study and kind of recruited some users to test out this system, initially we were kind of only talking with blind users, but then we realized some people who have low vision or like partial vision use screen readers like in conjunction with magnifier apps, for example. And using these different assistive technologies together kind of creates different situations and like different user needs that that might be different from what you would expect from like just using a screen reader alone. So yeah, it's a good question. There's like there's a whole range of different reasons why someone would use a screen reader.
On the topic of customizability, is the user able to change the order of things that are said? So I noticed when you're going through data points, it would say like, oh, this is from the same category, and then it would say the number.
That's a really good question. Yeah. I'll touch on this again a little later too, but in our prototypes, it's currently not possible, but it's something that we want to make possible. And it's something that we kind of realized was really important when we started evaluating, because like you said, different people will like find different kinds of information more important depending on like even what they're trying to do or like what information they're looking for. So any other questions? All right. Then I will continue. Is the screen sharing all good? Okay, cool. All right, so like I was kind of saying earlier, one of our goals in making some prototypes and going through this design process was to develop some design dimensions for thinking about like what's important to consider when making these accessible screen reader visualizations. And so in the process of kind of undertaking this project, we kind of work toward that goal using this iterative design process where we kind of went back and forth on a lot of different prototypes, tried out a lot of different things. And an important aspect of this process was the collaboration between the sighted members of our team who had more like data visualization, kind of like system design background, and our collaborator, Daniel, who is a blind researcher who has his PhD in human computer interaction and has a background in like science communication. and he's based out of London, and was collaborating with us on this project. And I'm sure y'all have talked about this a lot in this class, but terms like participatory and inclusive kind of get used a lot, and they mean a lot of different things to different people, right? And for us, at least, what it meant to kind of do this work well and do it carefully meant really engaging with Daniel's expertise, not only his expertise scientifically, in human-computer interaction, but also, his lived experience as someone who's blind and needs to work with data, right? And kind of weaving together like the different kinds of expertise that like everyone was bringing to the table, and really prioritizing, like really making sure that we were kind of addressing, actual needs, that we weren't just kind of imagining what we as sighted people thought was useful, right? So what this meant in practice was we kind of like, over the course of 6 months, every week, all of us would get together on Zoom. Some of us on the MIT side were kind of like making some of these software prototypes, and we would send them over to Daniel beforehand, and we would kind of chat about them every week. He wrote out, these really like long paragraphs of really detailed feedback, like really generously, and we kind of like tried a bunch of different stuff, and we're kind of figuring out together like what was working, what wasn't. And at the end of this process, we ended up with something like 15 prototypes and like this big archive of all of Daniel's feedback. And so we were kind of reflecting on the process and like all the outcomes of doing this iterative design process. And we were kind of trying to synthesize, what did we learn from this, right? What did we learn that might be helpful to other people who are trying to do this kind of design? And so we came up with this design dimensions framework that has three important components. So 3 like kinds of thing that you want to consider when you're designing, screen reader friendly visualizations. And we call these 3 things structure, navigation, and description. So I'm going to kind of step through each one of these one by one, starting with structure. So what do I mean by structure? The structure is this underlying representation of a visualization. And it's how we kind of like take the data and the visuals and like organize them into a format that you can traverse with a screen reader. So like take the chart and turn it into this thing that you can kind of step through with your arrow keys, right? And we kind of broke down structure into these 2 kind of components. One is form and one is entities. By form, I just mean like what shape is the data structure, right? So for example, if you take a look at this example scatter plot that is tagged with some alt text. This is an example from Vega Lite, which is like a very widely used JavaScript visualization library on the web. And let's just take a look at how this visualization is like represented to the screen reader.
Heading level 1, colored scatter plot. A scatter plot showing body mass and flicker lengths of penguins. A scatter plot showing x-axis titled flicker length mm for linear scale with value. Y-axis titled body mass g for linear scale with values from 2. Flicker length mm. Flicker length mm. Flicker length mm. Flicker length flip.
Cool. And that's like me kind of like, just mashing my right arrow key. So when you think about like the structure that this visualization interface has, right, with just kind of like default alt text tagging, you kind of end up with this little picture where you have the summary, then you have the x-axis, then the y-axis, and then data, like hundreds of data points, right? And because it's in this like linear structure, you can kind of only go like step back and forth one point at any time, right? So you kind of have to get through the x-axis and the y-axis to the data, and you have to like get all the way through all the data to even just go to the next thing on the page, like whatever's after that, right? So that's not ideal because no one wants to be stepping through like hundreds of data points. If you like compare that to the prototype I showed earlier, where we had this hierarchical structure, ours was more like this, right? We had the summary at the top. You could go down a level, and you could either go left and right between like x-axis, y-axis legend, or if you wanted to look at the x-axis and you didn't really care about the legend, you could just go down into the intervals and then further down to the data. So you don't have to inspect every single data point on the scatter plot, right? You can kind of like move up and down this hierarchical structure, and just pay attention to what you want to pay attention to. So that's structure. And then, so that's the form part of structure. And then the second part of structure is entities. And by this, I just mean like, what do the nodes represent, right? We tried a bunch of different prototypes of this. So different parts of the structure can represent things like data. So you could, imagine this line chart where the top of the structure kind of gives you information about the whole time range of this line chart from 2000 to 2010. And then you could go down one level and it maybe splits the time range in half, right? Just based on the data. And you're kind of, if you know what a binary search is, you're kind of just like binary searching in the data on this line chart. You could also, have a structure that represents what we call the encodings of the visualization, which is just, stuff like axes, legends. And that's exactly what we did in the prototype that I showed, right? So you have the summary at the top, x-axis legend for this bar chart, and going down into different categories and stuff. And then finally, you could imagine, instead of data or encodings, you could have summary and then parts of the structure representing like human-made annotations, right? So if you imagine this example line chart here with dates on the x-axis, whoever made this chart highlighted these two different date intervals in color because like something important happened during those dates, right? And the author wants to like draw your attention to that. So you could represent that in the structure too. So these are all, choices that you can make as you're designing these interfaces. So now navigation. We talked a little bit about these three kinds of navigation that we showed in the prototype. The first one we called structural navigation. So this is just, up and down to move between different levels in the structure, left and right to move through different things on the same level. This is exactly kind of what we showed as like the default way of navigating on the prototype. We also had spatial navigation, which is what I was showing on the grid view with the WASD keys. This is kind of moving up and down different squares on this grid. This grid, like kind of like you're feeling around a tactile graphic, like you have like a page in front of you or something. And then finally, we have targeted navigation, which is this idea of jumping directly to a part of the chart that you kind of already know you want to go to, but don't necessarily want to like figure out the path to get there. So three different kinds of navigation. And then finally, description. And this kind of gets to some of the questions about customizing those descriptions earlier. So we kind of broke down description into three different components. One is content. This chart is a little technical, but what we mean by content is basically like what kind of concepts are represented in the description, right? So you could have descriptions that are just about these kind of low-level concepts, like what chart type is it? Is it a bar chart or a scatter plot? What's the title? What are the ranges, etc. You could also have descriptions, that have like summary statistics, like average, min and max, outliers and stuff. You could be, you could have sentences that are talking about like complex trends and patterns and stuff. And you can go all the way up to having sentences that are talking about like things that would require kind of like social contextual knowledge to understand, right? So like things like current events, like explanations for why certain things happened in the data, right? And these are things that, you know, maybe like maybe you wouldn't necessarily be able to kind of auto-generate the same for every chart without like a human kind of supplying that additional context. And then there's you know, what we're calling composition, which is really just about the ordering of the information. So exactly like that question we got earlier, you can imagine, you know, someone who is going through different data points at the bottom level. And, you know, we want the important information to be at the front of the description because you don't want to have to like wait through a bunch of other words to hear the thing that you actually are looking for, right? So you want the important info up front, especially if you're kind of scrolling through a lot of data points, so you can just hear the thing and like know if it's the thing you're looking for or not, and kind of skip to the next one without having to listen to the whole description. But what's important kind of really depends on, you know, it depends on the user and maybe what their task is, right? So if you imagine someone who's looking through this this chart and they're looking for, maybe they're trying to find the first point that has category P, right? Then they would probably prefer this top description where category P is first, then 0.3 of 10, then like x equals 5, y equals 12. But, you know, what if that same person is looking through this chart and is like, I just want to know what the third point is, like what the x value of the third point is, right? Then you'd really want 0.3 out of 10 to be the first thing you hear, and then maybe, you know, x equals 5 be the next thing. So this is where customization would really come in handy, right? Being able to let the user like specify based on what they want, what order this information is coming to them. And then finally, verbosity, which is also kind of related to that earlier question about maybe the speed of reading, kind of related. By verbosity, we mean, you know, just how long are the descriptions and like how much kind of like context and like helper information are they providing? So you can imagine someone who's like pretty new to this system wanting to hear a description like interval with 6 values in the range 20 to 30. But what if someone's been using the system for like a year, they've heard that exact same sentence with different numbers so many times, they just want the numbers, right? So 6 values, 20 to 30, they know what that means. And it saves them a lot of time in the long run, right? So being able to customize verbosity too is definitely important to think about. Cool. So yeah, you know, as we were prototyping, we made a lot of these example data visualization structures just to kind of show that our prototypes represent this broader approach that can be reapplied more generally to a bunch of different types of charts. And we kind of evaluated this system using this evaluation where we recruited 13 blind and low vision participants. We interviewed them about their background with data visualization and statistics, and we also sat with them over Zoom for about an hour and asked them to use our interface to do a few kind of simple data tasks. And you know, we got a lot of really great insights from talking with our participants. One of them said, I liked having the ability to scroll through at a higher level and then drill down deeper if that's of interest. So they liked kind of being able to control their, you know, level of detail, information granularity, right? Another participant said, it gives me different ways of thinking. I'm thinking in more spatial terms. So it was kind of helping them like build this mental model in their head that maybe also would help them if they needed to communicate about the data with someone who's sighted, right? So if a blind and a sighted person are looking at the same COVID chart, or maybe there's like a line chart with multiple lines on it, both of them would be able to say like, oh, this line's above the other line, and that would mean something to both using this interface. And then, but like our participants also raised important points about the kind of learnability and usability of the systems. So one shared that I suspect that this might be understandable to someone who's done this before. I don't do well with these charts unless they're converted back into tables. So they were really familiar with this workflow of converting charts into tables and analyzing them that way. And that was working really well for them. So it was really important for them to be able to fall back to that existing workflow. And they also found the new interface kind of unfamiliar because it didn't really, resemble anything that they'd encountered before, right? Which is totally fair. So as we kind of think about like where to take this work next, right? We're kind of thinking about like, how do we make accessible experiences like this for visualization more common on the web? And one of the things we noticed was a lot of approaches to accessible visualization on the web. One, like take a lot of time to build, and two, they kind of don't have like UX, like user experience kind of standards or like conventions that everyone follows, right? So different visualizations might work differently for screen reader users, and that can be frustrating and kind of contributes to the problem that participant was talking about of like, it's hard to learn these new systems, especially when they're all different. So our thought is we want to be really building these default accessible experiences into toolkits and software libraries, so that one, it kind of takes less time to create these things, which means that visualization authors, developers can spend less time making things baseline accessible and spend more time on maybe more interesting things like customization and storytelling. And then if we build these accessible user experiences into toolkits that then get reused across different websites, users can learn a more standardized user experience that's the same across every visualization that's built using the same tool. And so I've been working with this really awesome undergrad intern in our lab who's been working on taking some of this work and building an open source library that's kind of more, more production ready, more like product like, right, than our research prototypes. And the idea is that you can kind of use, take existing visualizations created with like some of the more common visualization libraries and use our software to convert them automatically into these structures with different levels of description. Cool. And then finally, I think thinking about this problem space in terms of these three design dimensions can really help us not only kind of think about designing these screen reader interfaces for reading visualizations, but also think about other design questions. So some of the other things that we're thinking about in the lab include using different input-output modalities. So for example, if people don't use keyboards and use like non-standard buttons or like other assistive tech for motor impairments, for example, how do we kind of make that compatible? And thinking about different output modalities as well. So in addition to natural language, how can we think about structure, navigation, description for sonification, right? Like non-speech audio, or maybe for like tactile displays, for example, like braille displays that you can kind of attach via USB with screen readers sometimes. And we're also thinking about, not only being able to read kind of static visualizations, but how do you accessibly interact with visualizations. So when you see charts that have, zooming and panning around and things like that, how do we make that compatible with screen readers, or offer like a kind of equivalent, accessible experience? And then finally, accessible visualization authoring. So how do we make sure that blind and low vision folks aren't just thought of as passive consumers of visualization, but get to make their own visualizations and share them and do their own kind of data exploration? So that's all I've got in terms of presentation. I would love to kind of take your questions and talk about anything y'all want to talk about. But thank you so much for having me, and thanks for your attention today.
Jonathan, again, thank you so much for making the time for us here today. Anybody have any questions?
Yeah, I think listening to your presentation, it was extremely interesting. And funnily enough, for a physics assignment, I did a bit of research on your field of research previously. And I read that Daniel was blind. He went blind at the age of 16.
Mm-hmm.
Does he, when you compared him to other people with blindness, does he differ with his skills of understanding graphs, because he's probably previously seen graphs?
Yeah, that's a really fantastic question. So this definitely came up in a lot of our conversations with participants. We did find that there's a pretty broad range of people's, like the specifics of their disability and also their prior exposure to data and statistics. And these two things were kind of very related to how learnable they found our interface to be in the hour that they had to kind of try it out. And I think that is kind of a broader lesson in kind of doing this assistive technology disability work, where you kind of just have to remember that everyone's body is different, right? And so we want to strike that balance of creating tools and products and software that are general enough to be reusable and help multiple people, but yet still kind of be flexible enough to accommodate people's unique differences and preferences and needs. So yeah, it's definitely a tough line to walk, but yeah, really good question.
Yeah, thank you so much. I just read about your research a couple of months ago, and I never expected to actually personally talk to you. So.
Thanks.
I was wondering if you could do, because I don't know if we saw it, a demo of the screen reader, but with the box, if you know what I mean.
Yeah, sorry about that. Yeah, I'll screen share again. Yeah, so just pull up. I just always demo on this page, but
Voiceover on Safari.
okay.
Rich screen reader experiences for accessible. Frame 3. Web application.
Sorry.
You are currently on website not 2020. Link. Heading level 1. Rich screen reader experiences for accessible data visualization.
Is the box visible this time?
Yeah.
Cool. Yeah. So I'm basically, there's a voiceover command key, and then I press an arrow key to kind of advance the cursor, and it just highlights the next next block of text in the document.
Link. Jonathan Zong. Link. Chris. Link. Jiwon Carnegie Mellon University. Link. Daniel Hajj's Global Disability Innovation Hub. Link. Arvind Sakyanarayan MIT CSAIL.
Cool.
Voiceover off.
Does that help?
I have a question for you. So when you're designing something like this, right, and you talked about, right, sort of the design process of working with somebody with a disability, what was the biggest challenge that your team ran into while trying to create this?
Sorry, could you repeat the question? I was reading the chat, sorry.
No, you're all good. I don't blame you. Yeah, you talked about sort of the process of working with somebody with a disability. I was wondering what your team's biggest challenge was along that route.
Yeah, definitely. I think there's a lot of like different things I can think of, different kinds of answers. There were like kind of just basic process things that we all had to learn, like you know, on Zoom meetings the first few times, like just remembering to say who we were before, you know, launching into talking. Things like, you know, Google Docs is actually like not that great for screen reader accessibility, so keeping our notes in plain text files in Dropbox or over email so that Daniel could add to them more easily. To kind of broader things like just figuring out that kind of that iterative process of going back and forth and like bringing these different kinds of expertise. For me, you know, I came in with some like interface design background, some data visualization background. My laptop's running out of battery. But you know, I don't really know anything about the lived experience of being blind. And similarly, you know, Daniel, very luckily for us, has background in human-computer interaction, but was less familiar with kind of like the data visualization systems, like terms, like encodings and things like that. And so just kind of like making it so that everyone like kind of knew enough to speak the same language and like kind of come up with ideas together. Being really generous about like, you know, coming up with lots of different ideas, even if a lot of them were dumb, and like kind of being generous about like, yeah, like treating it as a process of like figuring out together like what works and what doesn't. You know, with the understanding that like a lot of stuff is just like not going to work. It's a hard problem. That's kind of just the way it is. So yeah, but I think, you know, ultimately very rewarding. I think, you know, we were very fortunate to have had Daniel take the time to agree to work with us. So.
Anybody else?
I know like you're focusing more on like the auditory aspect of like screen readers, and like I guess your future work is like exploring the input and like the outputs for these screen readers. But I was just like wondering, like, have you ever considered using like touch maybe to maybe help them allow them to like access the charts or images like better?
Yeah, definitely. I'm still kind of in the process of like brainstorming for what we're going to do next here, and that's definitely something that's come up. I think so some of the barriers for touch is that it's just like hard to make a lot of like tactile graphics quickly, and a lot of, you know, like commercially available things like Braille displays are really meant for text and not for kind of like 2D image displays. So there's definitely kind of, again, walking that balance of like, well, we want to make something that's like useful for most people using like what most people will have access to, but also wanting to like kind of explore and like kind of push on, you know, what we think is currently possible. But I'm personally very interested in especially like when we use these different modalities together. Like, so if you're using touch like combined with maybe like speech output, or like touch combined with like sonification, like different pitched tones and stuff like that, if that can like kind of be complementary and like enhance your understanding rather than kind of being treated as like separate things.
Yeah, I think like the first thing that came up to my mind when you were talking about like navigating the charts and everything, like the structural and all that different types of things, was like I think there was like I watched like a YouTube video that was like I think Stanford made like some 3D printing display or something. It was like the pins, and then I'm not sure if you're like familiar with it, but I guess like that's the first thing.
Media Lab has one of those.
Yeah.
Yeah, I think the Stanford project is probably from Sean Fulmer's lab, and Sean graduated from the Media Lab. So yeah, those are really exciting. And I'm excited to see where those go, and I'm hoping those, you know, become like, you know, more accessible like products at some point in the near future. So
Those also require an entire table.
yeah.
Oh, sorry.
Those also require an entire very specialized table.
Oh, I don't know. It's really interesting. Everything's interesting.
Yeah, thanks.
Have you guys like tried to do anything with like just phones or iPads and then using like the haptic engine to like kind of like simulate like buttons and stuff for like a touch interface?
Yeah, that is a conversation that we've had. We've had some we've done some prototypes of like mobile touchscreen stuff where like for example, like maybe dragging your finger around on a scatter plot will give you like sonified output depending on like how much data there is like underneath your finger, for example. We're still very like, you know, brainstormy phase with that, but I like the haptic engine idea. I don't know enough about like how these APIs work to know if like because I assume you probably can't like localize it to a specific position. You can kind of just like vibrate the whole phone or not.
I think the newer haptic engines, they have like 2 or 3, at least for like some new devices, they might have them in like multiple areas. I think they're trying to get it so it's in specific places of the screen, but I don't think they're there yet.
Yeah, that's really cool though. Yeah, so I don't know, maybe like in the near future when those have a bit more resolution, or even with like a few locations, I'm sure, you know, there's things that could be tried. But yeah, I feel like that's one of the like interesting and weird things about working in accessibility is that like the tech is changing so quickly, and also there's like no standardization at all. So it's really like there's a lot of exploration that you can do. There's also just like a lot of ways to like, there's a lot of things to try, and like it's not totally clear to anyone like what's correct right now. So like exciting to work on. Yeah.
All right, guys. I mean, if we don't have any more questions for Jonathan, I think I can stand for all of us and say thank you so much. And it was incredibly educational to hear about your research and what you've done. So thank you for making the time.
Of course, thank you for having me. Thanks to Jose in particular for reaching out and making the invitation. But it's great to meet all of you. I'm excited to hear about where your projects go.